Hello, in this video we'll go through some very basics of PSIM, also known as power sim. We'll build a half-wave rectifier, we'll measure the input and output voltage. So let's get started. First let me introduce to the interface. We have the menu bar, file, edit, view, design suites, subcircuits. Then we have the library browser. Here we can find our different components. Using these components we can synthesize our circuit. And then we have at the bottom we have the commonly used or mostly used components. So we can also use these to drag and drop to our environment, and we can use them in our circuits and then simulate. To create a new file, we can go to the file and new, and it gives us the space where we can create our circuit. So now we can use our library browser to find our components that we want and drag it to the working environment, and then we can connect them and simulate. So we can use this edit box to search for the required components. For instance, I want to find a resistor, so I'll just type in a resistor and it gives us these different options. So I can just click, and as I move my cursor you can see that the resistor is attached to the cursor. So I can just click and it will be placed. If I right click, I can rotate the resistor. So unless I press escape, the resistor will still be attached to the cursor. So I can even make multiple copies. So I'll just press escape and I'll delete one of the resistor and I'll keep the other, and this will serve as my load resistor. To zoom in, I can hold my control key and scroll. I can use the mouse wheel to zoom in and zoom out. Once placed, I can use these options to rotate or flip or disable my component. So if I want to rotate it by 90 degree, I'll select the component and click the rotate option, and it will be rotated by 90 degree. Click again, click again, click again. So you can see that you can rotate or flip the component by using these controls. Just select and drag if you want to readjust your circuit at any moment. Okay, now let's move to find a diode. So just type in diode and you can select the diode from here, or you can also see here is a diode. Here is also, you can also find a resistor. So we can also bring these components from this quick access bar, and we can also search in this library browser. So I'll just click the diode and I can click here in the editor window. I can press escape and no more diode will be added to our environment or canvas. One more thing that we need here is the source, the AC source. So I'll go to the sources. This time I want to do it manually, and to the voltage sources, because the library browser is it's arranged in different groups. So I can straight away go to the sources and I can spot the voltage. So these are the different voltage sources, like the DC, the battery. I'll select the sine, so it will give me a sinusoidal output. Okay, I would like to add the ground, and this time I'll use this kind of quick access and press escape. Now the next step is to connect these components. So I'll use this wire, we can use the short key W, and you can see that the cursor has been changed into a pen. That means you can connect these components now. I can connect the cathode of the diode to the resistor, and further I would like to add resistor to the ground, also this terminal to the ground. Okay, that's great. I'll press escape and we'll get out of this wire mode. Okay, so this circuit is now kind of complete, but the next thing that's important is the measurement. What are the voltages and currents that we want to measure? So to measure the voltage, for instance, I can use this voltage probe, and I'll click over here, and this will add a voltage measurement probe, one at the load side and one at the source side, and I can now connect them with the required nodes. Okay, I can just double click now each component and I can edit the parameters. Okay, this is the next level. Okay, so we are done with the placement and wiring. Now the next step is the parameter updation. We can update the parameters as per our requirement. For instance, the source voltage, I'll just double click. The source frequency at the moment, the cyclic frequency is 60, and the peak amplitude is 110. If I want to display any of these parameters, I can just check this box. For instance, I want to display the peak voltage, so you can see that the peak voltage is displayed here, and similarly there is a label V1 that represents the source voltage over here. So I can also check that and move it, drag it to the appropriate position. So now we can see that its source voltage is represented by V1 and the peak voltage is 110. We can also check the frequency, but that will be too much information over here in this limited space. Okay, similarly we can double click the diode, and for this particular simulation we are using the ideal diode. So the ideal, we can also go for some detailed models where we can incorporate the diode conduction losses and the forward voltage drop, things like that. For the moment we are sticking to the ideal model. Now the load resistance, it's labeled as R1. We can also change the label, by the way, if we want. And there is the resistance. So the load resistance is 10 ohm. We can drag it just like this. Okay, so this is the kind of circuit we are going to simulate. And yeah, the probes, for instance, I want to name it like the V in, and let me label it V out. So these labels are kind of easy to read, or that easy to memorize. In other words, we can memorize like V in represents the input voltage, V out represents the output voltage, giving it some vague names, for instance V1, V2, that will keep you guessing whether it's the input voltage or whether it's the output voltage. So better use some meaningful labels. So I have replaced the label of this. I can even check to display the label. I can display the labels by checking this box. Okay, so now we are good to simulate this circuit. So we'll proceed and run this simulation. Okay, now you can see that we have two available variables. it's called V in and V out. If we remember, we just assign these labels to the input and the output voltage respectively. So if I click one of them and press add and then press OK, then you'll see that the V in is displayed in our display window. And if I want to add the other one as well, I can just click V out and add, press OK, and we have V in and V out plotted in the same axis. So since we have the ideal diode at the moment, so you can see that V in is kind of overlapped over the V out, so you can only see the blue one here. So you can get rid of just click this option, press V in and remove, and we'll be left with V out only. So this is the output waveform, and it was the very basic introduction. So it was just to show you the process flow, how the things goes from creating a new file all the way to simulating and displaying the results. And we'll further look into how we can change things as required, and maybe some tips and tricks how to improve the visibility of the results, how to export them, and how to make like a DC to DC circuit. We have active switches. Here we have a passive switch which doesn't need external control signal, a switching signal. So it's a kind of easier version, and we can go for more advanced version in the next video.